Alright, hey guys, this is 8.2 Polar Equations and Graphs. I'm mainly going to talk about polar equations and how to convert between polar equations to rectangular equations and vice versa. So let's say I have this equation right here, r equals 3. A lot of stuff that we're going to use goes back to what we did, or I guess we didn't do it, but right here, this converting equation. So x equals r cosine theta, y equals r sine theta, and then rectangular to polar, r equals the square root of x squared plus y squared, and theta equals tangent inverse of y over x. And we did use that stuff right there when we were finding polar coordinates. Okay, so we are going to use the same principles as we did with coordinates, but this time we're applying them to equations. Okay. So we're going to start right here with this first one, r equals 3, and it's pretty simple. You can see in the picture, it already has it graphed for you, that it is a circle, okay? So r, it says, is equal to the square root of x squared, x squared plus y squared, so I can substitute that in, equals 3. Now, I want to kind of simplify this a little bit, so I'm going to square both sides, and I get x squared plus y squared equals 9. Now, this looks like something that you've done before in math classes. Okay, this is your formula for a circle, so we're going to kind of simplify it out and write out all the parts. So you can see also from your picture, and we'll talk about how to graph it later on in your calculator, that this is a circle. The center, because I don't have anything with the x or the y, the center is at 0, 0. Remember, this is r squared, so the radius equals 3. Okay, and you can also see that from your picture. To go from the center, it's at 0, 0, and the radius is 3. Alright, so theta equals pi over 4. So the easiest way to kind of do this one is I would take the tangent of both sides. So we have tangent of theta equals tangent of pi over 4. Okay, so we know tangent of pi over 4. Okay, that's on our unit circle, that equals 1. So we're left with tangent of theta equals 1. Alright, now we know from what we did up above that tangent of theta, okay, what we're looking for is just going to be y over x. Okay, and that comes from right here, that theta equals tangent inverse of y over x. So if we're actually trying to find, that's if we're actually trying to find theta. Okay, so y over x equals 1. Okay, and we can go ahead and solve for y here. So we're going to multiply both sides by x. This keeps doing this. All right, and so we get y equals x. So this is just your basic linear equation. So it's a line with a slope of 1 and a y-intercept of 0. Okay. All right, next one. So again, it already has it graphed for you. So this one we just have to recognize r sine of theta, that just equals y. So all we have here is y equals 2. We can recognize that this is a horizontal line. You could also maybe say the slope is 0. That's pretty much all you can say about that one. Alright, so next we're going to talk about how to graph this in your calculator. It won't allow me to switch screens in here, so we'll do this in class also, but I'm going to kind of go through these as well. What I'm going to do first is actually go through how to solve all these, and then we'll go through them in the calculator, and I'll go through the calculator process. So one thing to know, I'm going to go through first of all what the equation is for all of them, okay? And then I'm going to go through how you would type it in your calculator. When you type it in your calculator, you'll notice it says that you have to solve for r. So just like when you're doing your calculator, you have to solve for y. In rectangular, you have to solve for r. But first, we're just going to do just like we did before. Okay, this is actually the one that we just had, so this should look like y equals 2. All right, our cosine of theta, that should look like x equals -3. So that one's actually going to be a vertical line. Okay. All right, now this one is a little bit more complicated. So I don't have, you notice this one is 4 sine of theta, there's no r on either side. So what I'm going to do is I'm going to multiply both sides by r. So I get r squared equals 4r sine of theta. Okay, so now I have this r sine of theta. Okay, and I know that r sine of theta equals y. So this is just 4y, and r squared is x squared plus y squared. All right, so now I have something that looks like a circle, but I have to actually solve it, and we're going to go back to something we did at the very beginning of the year and that you did in Math 3, and that is completing the square. Okay, so I'm going to start by getting everything on one side. So x squared plus y squared minus 4y, because you got to get everything on one side, plus blank equals 0. Okay, so again, we want to get it in the format of x minus h squared plus y minus k squared equals r squared. Remember, that's your format for a circle. Okay, so in order to do that, I'm going to take the middle number, divide by 2, which is -2, and square it. So I take my -2 and square, that's 4, and so then I have to add 4 on the right. So I end up with x squared plus y minus 2 squared, that just came from whatever number was in my parentheses, equals 4. So that's my rectangular equation. Okay, this is still a circle, but my center here is at 0, 2, opposite of what's inside your parentheses, and the radius is 2, because remember that 4 is the radius squared. Okay, so we're going to do one more just like that, and then we're going to go back and solve for r and all of these, and I'll tell you how to put them in your calculator. All right, so this one right here. So again, I don't have r cosine theta, so I need to multiply both sides by r. So over here, r squared is x squared plus y squared, and then r cosine theta is -2x. Okay, so then I recognize that this is going to be a circle, so I'm going to move everything on the other side. So x squared plus 2x, I'm going to leave myself a little bit of room because I know I'm going to have to complete the square, equals 0. Okay, so divide by 2 is 1, squared is 1, add 1 to the other side. Remember, whatever you do to the left, you have to do to the right. So I end up with x plus 1 squared plus y squared equals 1. Okay, so this is a circle with the center at -1, 0, sorry, -1, 0, because opposite of what's in your parentheses, and then the radius is 1, okay, because the square root of 1 is still 1, okay? All right, now to put these in your calculator, there's a special mode that you're going to use. First of all, you notice that your calculator should be in radian mode, and then polar mode. So in order to do that, you're just going to go to mode. Again, it won't let me to show the calculator screen, which is kind of annoying, but if you go to mode and make sure that your calculator is in both radian mode and polar mode. Okay. Next, again, you have to solve for r. So in this one, what we're going to have to do to solve for r is r equals 2 divided by sine of theta. Okay, so the first thing you do, make sure you're in radian mode and polar mode, and then 2 divided by sine of theta. And once you change it to polar mode, when you hit the X button, it'll automatically turn into a theta. And then when you graph that, it should look like a horizontal line at y equals 2. All right, same thing for the next one. When we solve for r, it should be r equals -3 divided by cosine of theta. Okay, and when you graph that one in your calculator, it should turn into a vertical line over at x equals -3. Now the last two are already solved for r, so we don't have to do that work there. So for sine of theta, okay, so the center is at 0, 2, okay, and the radius is 2. So it should end up with hopefully looking somewhat better than that, okay? Something you'll notice, I'm actually going to do this one first and then I'll tell you that. So, and then the last one is a -2 cosine of theta. So -1, 0, and the radius of 1. So something you'll notice that's not a coincidence. So this one up here was a sine graph, and you'll notice it lies on the y-axis, not an English teacher here. It lies on the y-axis, and sine is y, okay? This one is cosine, and it lies on the x-axis, okay? That's not a coincidence, okay? So when you have a circle, if it's a sine, it's going to lie on the y-axis, and think about it, that's because you have an x squared that's 0, okay? And if you have just r equals cosine, that's going to lie on the x-axis, okay? So that's not a coincidence, that's a pattern that's going to occur there, okay? So that's kind of how you convert between equations that are polar and rectangular, okay? We'll get into a little bit more of the patterns that you'll see in class, but that's kind of the gist of equations.